Okay, so we just talked about this. We're learning about the exponential property of equality, the exponent property of equality, and a happy meal property. There it is again in purple, what we saw before. If the two bases are the same and they're equal, then the two exponents have to be the same. Let's just show a couple easy examples. There was one exception. Can you think about what it is? Here are some easy examples. If 2 to the x power is the same as 2 to the 5 power, 2 to the 5th power, then x has to be equal to 5. I mean, that just makes sense. 2 to the 5 has to equal 2 to the 5. Over here, we run into a bit of a quandary, kind of why this is a happy meal property problem. 3 to some power equals 27. Those are not the same boxes. They're not the same size box of happy meal. I can't say, well, x equals 1, the exponents are equal, because the bases aren't the same. Up here, the bases had to be the same. Well, it turns out on this one, it's pretty easy. I can rewrite 27 as 3 to the 3rd power, thus giving them matching boxes. So then I can say, oh, okay, they have the same box, their contents must be the same. X has to equal 3 in that variation. Okay, let's try this one. Skill 3, we're evaluating log base 4 of 8. All right, so that was skill 2, was to evaluate logarithms. To do it, we set whatever we're trying to evaluate equal to x. Okay, now I got to figure out what x is. So then we go back to skill 1. You see how all this stuff just builds on itself? Skill 1 was to rewrite a logarithm as an exponent. Okay, so I'm left with 4 to the x power equals 8, and we're kind of stuck until skill 3 comes along. I can't say that these exponents are the same, right? This is an exponent of 1, this is an exponent of x, because the boxes aren't the same, the bases aren't the same, so I can't do that. I need to get matching bases to make this property happen, to use the happy meal property. Well, it just so happens I can rewrite 8 as 2 to the 3rd power, and I can rewrite 4 as 2 to the 2nd power. They have matching bases. I'm getting them to be the same box, the same happy meal box, so I can compare their contents. So here's what I just said. 8 is 2 to the 3rd. 4 is 2 squared. Now with a little bit of exponent rules, a power raised to another power, we multiply those. That just becomes 2x. Now we can use the exponent property of equality and say, oh, they do have matching bases, so their exponents must be the same. 2x has to equal 3. And then I can just divide and say x is 1.5. So back at the very beginning, log base 4 of 8, that's what we were trying to figure out. Log base 4 of 8 is actually equal to 3 halves, 1.5. Okay? That is the happy meal property. Why don't you guys try these 3 on your own? Hit pause and then come back and we'll look at them. Okay, we're back. I'm going to attempt to block out half of them, some of them, while I go over the other ones. So let's take a look. How creative can I be? There it is, written as an exponential. Log base 4 of 1/16 is equal to something, x. Then I rewrite it as an exponential. 4 to some power is 1/16. I need matching bases. We have options here in this. I could rewrite 16 down here as 4 squared. Then I have 1 over 4 squared. Well, 1 over 4 squared, again, exponent rules, need some algebra 2 review here, it's actually 4 to the negative 2nd power. Now they have matching bases. They have matching bases, then their exponents must be equal. X equals negative 2. Check. Let's try the next one. Creative, pretend like you saw nothing. Jedi mind powers. Log base 25 of 5 is equal to something. So I'm going to set it equal to x, and then write it as an exponential. Matching bases here. Let's see. 25 to some power equals 5. Well, I can rewrite 25 as 5 squared. 5 squared to the x power, a power to a power, you would multiply. And I'm left with this. Matching bases. 5 to the 2x equals 5 to the 1. I can then say, well, if the bases are the same, then the exponents must be the same. And I can solve it, and I would get x equals 1/2. Okay? Last one. This is an interesting one. It kind of looks like it could be an exponential, but it's actually a logarithm with an exponential inside of it. Wow. Okay, so it's equal to something. It's equal to x. So I would just set this whole thing equal to x, and then I would write it as an exponential. 5 to the x power equals this whole thing, 5 to the 11. Wow. Kind of fell into my lap there. Matching bases. Awesome. If they have matching bases, their exponents are equal, and we're left with 11. This is kind of a property here. This is showing something that's going to come up in our notes coming up. But if I have log base 5 of 5 to a power, log base 5 and base 5 cancel each other out, and I'm just going to be left with that power 11. All right, that's the Happy Meal property. Let's go through on the next slide and practice some. Moving on.